Merced Physics Graduate Program recruitment webinar. So I am Chih-Chun. People usually just call me Triple C. I am the Physics Graduate Program Chair here at UC Merced, and our department is as young as you are, and we are very energetic, and we are welcoming new students. We have several faculties here, so we will take turns and introduce ourselves first, and then I will give like hopefully 15-20 minutes overview of our physics program, and then we will open the floor to questions. So I will be the first to introduce myself. So I'm Triple C, and my research is on using quantum physics to understand atomic, molecular, or condensed matter systems. And I'm interested in those super stuff like superfluids, superconductors in materials, and what are the many body physics behind those complicated phenomena. And more recently, I am interested in using geometric or topological ideas to explain physical phenomena or search for new many body physics in complex systems. I already graduated 4 PhD students, and I'm certainly looking for mentoring more new students. And now I will turn the floor to Kevin.
Hi, I'm Kevin Mitchell. I have been here at UC Merced since the good old days, 2004. I study nonlinear dynamics and chaos theory, which can be applied to numerous areas of physics, engineering, and applied math. Pretty much any physical process you can think of has some nonlinear version of it. So nonlinear dynamics is a very broad interdisciplinary area. My own research interests I would characterize as spanning from the sort of fundamental theory, almost math, applied math, pure math even, side up through applications to experimental systems and kind of everything in between. Experimental systems that I've been looking at, I don't do experiments myself, but in collaboration with experimentalists. The systems I've been looking at most recently have involved fluid dynamics, soft matter, even some biophysics, looking at, say, swimming organisms in complex fluid flows. And in the past, and even still to some extent today, I've also been looking at applications in AMO, atomic molecular optical physics, although I've been kind of swept up in the soft matter and biophysics area for the last several years. And I'm looking for new students myself as well.
And then Jay, would you like to go next?
Sure, yeah, my name is Jay Sharping. I'm gonna just put a slide up because I have it. So here's a picture of my group as it currently stands. There's a couple of undergraduates depicted here, Javier and Cameron, and 3 graduate students, Harry, Jonathan Daniel, and Albert Di Benedetto. And we do, it's called Applied Photonics Group a little bit, but maybe I should change the name as more of a quantum physics group. Shown back here behind Harry is the inside of a dilution refrigerator, and we're using those instruments to perform experiments at very low temperatures where materials behave a little bit differently. And for example, you can get superconducting materials very conveniently at this low temperature. And one of the experiments that we are working on is to do levitation of a magnet inside of a superconducting cavity where there's also an electromagnetic resonant mode. So what's really interesting about this is as the magnet bobs around here, just a question, are you seeing the presentation or are you seeing,
Yes.
okay, looks good. Okay, as the magnet bobs around here, the resonant frequency of this cavity changes. And there's other things that cause the resonance frequency to change also, such as a thing called the transmon qubit. So this transmon qubit is one of the core pieces of the state-of-the-art quantum computer these days. And there's another thing here called a magnon. These are all quantum objects. And what we would like to do is to somehow have this classical oscillator coupled with these other objects and maybe push the limits so that this classical oscillator starts to exhibit quantum behavior. So there's a lot of interesting work about figuring out just how the magnet bobs around, how it affects the frequency of the cavity, and how to build this this apparatus to do exactly what we want it to do. Yeah, so that's one of the experiments that I've been working on. Listed here also are Jeffrey Miller and Nabin Raut. Jeff and Nabin graduated from my group just earlier this spring. And Jeff is at the Pacific Northwest Laboratory, building a quantum computer there. And Nabin is at the Jefferson Accelerator Laboratory working with superconducting radio frequency cavities. I guess I'll let somebody else go next. Maybe Lynn.
Lynn.
Yeah. Okay. Great. Thank you. So my name is Lynn Chien. I'm a theoretical physics here at UC Merced. I also have been here for a while. I came here 2008. So in my group, we study quantum computing and quantum networking. So some of the research is related with studying, the physics side of the quantum information science. For example, we look at novel many-body physics with a special purpose quantum computer called quantum simulator. We also look at, for example, adiabatic effects, basically how adiabatic process can be used to enhance quantum computing. So we also study quantum networking with interfaces to connect different quantum systems, basically building scalable quantum network that can basically eventually enhance quantum computing to a larger scale. So in my research, we basically use techniques in condensed matter physics and also quantum optics, because we are interested in both the many-body effect and the quantum coherent effect in engineered quantum systems, including, for example, superconducting qubits, optomechanics, trapped ion systems. I also have a slide basically inspired by what Jay has showed you. Let me just show you a slide right now. This is something I prepared for something else, but it gave you an idea of what are some of the projects we study. If you look at the first part on the left-hand side of this slide, we have basically quantum simulator. So it's made of a bunch of qubits and also can be oscillator mode. It could be simply superconducting qubits coupled to superconducting cavity modes. And you want to look at the collective effect, many-body effect, and novel computational advantage in such system. On the right-hand side, this is basically one subject related to quantum networking effort in my group. So you can talk about interface to different system, eventually can be extended to a larger scale. So right now I'm accepting new students because I have 2 graduate students graduated in the past 2 years. So I'm actually eagerly looking for students to join my group to participate in some of those projects. So if you have any question, you can feel free to contact me either right now or send me an email. Thank you so much. I think that's me.
Okay.
Yeah.
Okay. So now it's my turn to give you a hopefully 15-minute overview of our program. And the other faculties, please help check the chat box in case there are like questions. So so can everyone see the overview slides?
Yeah. Okay,
good. Okay, so I'm Chih-Chun, and I'm the physics graduate program chair, and Professor Kevin Mitchell is also here. He is the physics graduate admission chair. So if you have any questions about applications or our programs, you're welcome to contact us. So where is Merced exactly? Say Merced actually is in the geometry center of California, in the sense that you can see that this is California, right? And we are in the middle of California. We are about 2.5 hour drive to San Francisco, and about 1.5 hour drive to Yosemite National Park. UC Merced was founded in 2005, and Professor Kevin Mitchell is one of our founding professor. UC Merced is the 10th campus of the University of California system, and interestingly, we are the first U.S. Research university built in the 21st century. The city of Merced has a population about 80,000, and the campus just finished what we call the 2020 project that doubles the size of the campus with lots of novel, new buildings and new research facilities. Since we are in the center of California, we are near many major research universities and laboratories. For example, Stanford, Berkeley, Davis, Santa Cruz, and also the UC Lick Observatory, and also national laboratories like Lawrence Livermore, Lawrence Berkeley, or the NASA Ames Research Center are within driving distance. So a brief introduction to the department. We have 20 faculty members, and among the 20, we have 7 women faculty, which is 3 times higher than the national average. And in addition to the physics faculty, we also have 15 affiliated faculties from other departments. They are certified to mentor physics graduate students. Right now, we have about 65 graduate students, and a quarter of them are women. And our students are coming not only from, say, California, but also from other states and also many other many countries. For the undergraduate program, we have about 65 physics majors. And for the whole UC Merced, right now we have about 9,100 undergraduates, and about 55 of them are Hispanic. And we also have a very high percentage of first-generation students. So for the research in the department, we can roughly divide it into these 4 branches. So the first one is atomic, molecular, and optical physics, which you heard introductions from Professor Mitchell, Professor Shopping, and Professor Chien. And so in this branch, say, research groups use optical or electromagnetic methods to probe, for example, quantum dots, solar materials, superconductors, or biological molecules. And on the theory side, we are working on various theoretical descriptions of those complex interactions. And then there is this branch you heard from Professor Mitchell, that we have this branch including biophysics and the soft matter, and they study large scale or statistical behavior in complex materials or matter. And for example, like liquid crystal, fluid complex fluids, bio-inspired materials, or bacteria or cells, and also use say on the theory side, people are using statistical mechanics or other methods to understand those complicated phenomena. And then there is this condensed matter and the solar energy branch where say people study, for example, two-dimensional novel materials, superconductors, solar materials, and quantum dot materials, or other novel quantum materials. And on the theory side, we are trying to understand those complex systems using quantum mechanics. We have a new branch that was established in 2020 on astrophysics and astronomy. So right now we have two new faculties. On the observation side, we have Professor Anna Nierenberg working on data from those working on data from large observatories, and we have Professor Sarah Lobman working on theories and simulations of, for example, galaxy dynamics and the formation. We have 15 affiliated faculties from several different departments, and they are certified to mentor physics graduate students. So in addition to the physics core faculty, our students can also seek supervision from those affiliated faculty. We have several centers that provide training and fellowships for our students. For example, this Merced Center, Merced Nano Technology for Nano Material Center for Energy and Sensing. It's sponsored by NASA, and it's focusing on using physics, chemistry, or math to understand materials or physics or phenomena related to aero industry. And this center provides several fellowships and also training courses for both undergraduate and graduate students. And we have another center called CCBM, Center for Cellular and Biomolecular Machines. And it's a large-scale center that has several projects, and it provides both training courses as well as fellowships for graduate students, and it has lots of activities going on every year. We have two what we call training fellowships that are targeting incoming or new students. So the first one is called iBioStep or GRISE Training Fellowship, and we will hear about this more from Professor Ajay Gopinathan. So for this training fellowship, it will sponsor an incoming students for the first 2 years, working on interfacing biology and physics and engineering. So say when you apply for our program, actually you can indicate if you want to be considered for this training fellowship. And then we have another training program called Condesa, and it's a program that's interfacing physics and environmental science. And we have 3 faculty members on this training program. And the training program also provides fellowships and the training courses for our incoming students. So for applications, the application is online, so you can go to the graduate division website to submit your application material. There are 2 deadlines. If you submit your complete application before December 16th, then your application will receive priority review. And what that means is that you may receive early offers if you complete your application by the priority deadline. On the other hand, the general deadline is January 15th next year, and applications submitted before the general deadline will be fully reviewed. And the requirement is that you need a bachelor or master degree in physics or closely related fields. And for this year, GRE scores are not required, but if you have them and you want us to consider, then you can submit that as supplemental information. And we need transcripts from your previous institution or your current institution, and also 3 letters of recommendations from your research supervisor or professors. And you need to submit your CV and the statement of purpose. And for international students, you need to submit your TOEFL or IELTS scores. And for the requirements, you can find them on the graduate division website. If you have other additional materials, you can submit them as supplemental information along with your package. And if you have any questions about fee waivers, you are welcome to contact Professor Kevin Mitchell, and we will consider your request. More details can be found on the graduate division application website. So for course requirements, say for the core courses that students need to complete, including a review course on undergraduate knowledge and the 4 core courses at the graduate level. And then students are required to take 2 elective courses along with additional physics colloquium and other types of courses. For the degree requirements, students need to pass the review course on undergraduate level knowledge and also pass the qualifying exam. The qualifying exam is testing your proposed research for the thesis study. So those are the 2 exams. And then at the end, students will defend and submit their thesis. For first-year students, we actually don't, we have the rotation system in the sense that students don't need to select advisors right away when they enter the program. You are encouraged to contact our faculty, but having an advisor is not required. So in the first semester, we will match you with a faculty that's that you may be interested in his or her research, and then you can do rotation research in your rotation advisors group. And then a student may request a second semester rotation with another faculty before settling into a research group. And usually our first year students are serving as teaching assistant, so they need to lead undergraduate discussion or labs. We have both peer mentoring program and from the graduate division, where each incoming student will be assigned a senior peer mentor, and also the rotation faculty will be the faculty mentor for our first year students. So here is a typical timeline of PhD study here at UC Merced. So in year 1, students will complete are usually completing their core courses while doing PA and also trying to find a research group that they can join. And then in year 2, they start doing research, form their thesis committee, and take elective courses. In year 3, they will continue their research and then advance to candidacy by presenting their research proposal. And then from year 4 on, they will complete their research and complete their thesis. There are benchmarks that will gauge if a student is on the right track toward completion. So regarding financial support, all our admitted students will receive 5-year funding guarantee, in the sense that within 5 years, the student should receive one of the 3 types of financial support, either from teaching assistantship or graduate student researcher GSR, or from fellowships. And typical stipend will be around 27,000 a year, but say the number will increase according to the school. Merced has the advantage that the living cost is relatively reasonable compared to other places in California, and so our students are actually have they have quite decent life. Say here are some places where our PhD graduates move on to. So some of them continue their research as postdoctoral researcher or become faculty in some schools. Some of them move on to industry, and some of them serve in government facilities or agencies. So this is a brief overview of our program, and I hope you are interested in applying for our program and joining us. If you have more questions about applications, you are welcome to contact Professor Kevin Mitchell, or for general questions, you can contact the graduate admission, and there are other places you can find more info. And I will stop here for my presentation, and let's see if, Ajay is here. So Professor Gopinathan will give us an overview of one of the center and also one of the trainee fellowship program. Ajay.
Thanks, Chih-Chun. So let me just share. All right. Okay. So I guess I can start with this. Right. So let me say a few words about the center. I guess I didn't have a slide, but or at least I don't know what I did with my slide. So the Center for Cellular Biomolecular Machines is a NSF-funded center, and Chih-Chun mentioned a little bit about it. And so it has about 25 to 30 faculty, labs in it, and so more than 100 graduate students and postdocs. So it's a large center spanning, mostly physics, bioengineering, and also chemistry and chemical biology, and materials and biomaterials. So those are the main groups that are, but we also have people from biology and applied math and so on. So it's a very interdisciplinary group of people, and the idea is to bring kind of physical and engineering approaches to attack biological problems and to be inspired by biological problems, and develop novel physical theories, applications, or even materials. So that's kind of the intellectual thrust of the center. What do you gain by being part of the center? Of course, exposure to all of this, exciting research, ability to collaborate, access to resources that the center has. So these resources include, depending on what you do, whether if you're an experimentalist, we have a mass spectrometer, it's top of the line. We have access to other fabrication facilities. We also have a computational cluster and standalone workstations for image processing and so on. And we also do hands-on workshops on nanobiofabrication, imaging and spectroscopy, and computational modeling. And so these are all things that we offer through the center, which you would have access to. And we also, most importantly, fund fellows. So we actually And so this is for students who typically have been here for more than a year. And so you're part of a group, which is part of the center. And then you can actually apply to be a fellow of the center, which means you'll be funded by the center. And therefore, you wouldn't have to do a TA share or a GSR. That's about the center. And then let me talk about the this is an NIH funded training program. So it's a graduate training program, and so it's specifically meant to recruit graduate students into different programs. And this is also has a lot of overlap in theme, which is also to bring together physical and biological, so physical and engineering perspectives to more specifically biomedical field, and to train students to enter these biomedical fields. And there's this is a set of students, graduate groups that are participating in this training program. In terms of faculty labs, there's a lot of overlap with the CCBM, the center, the NSF center I mentioned, and it's actually slightly larger in terms of the number of people who are participating. And so here we recruit students directly into this program during your application. And so how does that work? So before I tell you that, let me first tell you what are the advantages of being part of this training program. Again, this has a very well-structured training program. So it has courses, it has workshops, it has professional development workshops, as well as career advancement workshops. And you can find out more about the details, because I don't want to take up too much of your time. You can go to our website and look at these. And there's also, I've tried to include kind of a generic timeline of what students would go through as they go through this program. And it starts early in the summer before you actually join. So we encourage, or we actually pay for our incoming cohort to actually be part of a summer bridge program, which gets you acclimatized to graduate life at UC Merced, and also gets you a head start on research, because you start working with some PIs right at the beginning. And then, of course, as you go through, typically you would be doing courses in your particular graduate group. So you are all physicists, presumably, or you want to be in the physics graduate program. You would do your first year physics graduate courses, just like part of your physics cohort. And then in the second year, through this program, we offer specific electives, and you can use those electives as electives in your physics graduate program as well. And so you can take those, they don't add to any time, but that's part of the training program, because it's training you for particular things. So these courses are on computation and modeling of biological systems, also imaging and spectroscopy. And finally, we have a Frontiers of Biotechnology course that's new, that's coming up next semester. So taking these 3 courses will also set you up to get what is known as a graduate designated emphasis that we're working on. And so that'll be kind of like a graduate minor in this field. Of course, you get paid, and this is the main, one of the main attractions of doing a fellowship is you have a full 2 years fully covered by the grant, by the training program, including tuition and fees and benefits. And this also means you wouldn't have to be a teaching assistant. So again, it frees up a lot of your time to devote towards research and get further ahead. I talked about the other things. The other thing I wanted to mention was also travel support. So we actually have a specific pot of money to support the fellows' travels to different conferences and workshops during these first 2 years. So how do you apply to this? You follow the same application process. When you look at your graduate application form, you will at some point run across this, where you'll see that below where you put down your program information, there will be a little section which says GRISE program. And then it gives you a little bit of information about the program and some links, so you can click on it to find out more. And it asks, do you wish to be considered for the fellowship? And if yes, and if you're interested in these fields of study, and you're coming through one of the eligible graduate programs, then you should feel free to say yes. And of course, as per NIH guidelines, people who, we can only fund domestic students, so just keep our permanent residents, so please keep that in mind. And then we also require you to put down a little paragraph about why you're interested in fellowship. I highly recommend you do put down something there because it's a very competitive fellowship. We get about 80 applicants a year, and we only have 6 slots a year. So and the cohort is about 6 to 8, depending on the actual budget, but that's about it. So yeah, and if you have any more questions about this program or the center, please feel free to reach out to me. I can put my email in the chat, and I'll also put down the links to the CCBM and GRISE. All right, thank you. Thanks, Chih-Chun.
You are great. Okay, so now we open the floor to the audience questions. So if you have any questions, you can either click the raise hand, or you can unmute yourself and start asking questions, or you can type your questions in the chat box. Yes, Alexander, you would like to ask a question?
I was trying to do the raise hand thing, but apparently Zoom doesn't want to.
Yeah.
Sorry, I'll do it the old-fashioned
No problem.
way.
No problem.
I had a question. The Condesa program, the Convergence of Nano-Engineered Devices, is that, I might have missed something. I'm like hopping back and forth between a couple of things. Is that also part of the application, or is only the iBio step on there?
Instead, they have like a box already on the application forms that you can check that you want to be considered. On the other hand, the Condesa program, they will ask for applications in the first semester when students come into the program. So because of their different operational models, so for the GRISE or iBio step, say we encourage the applicants directly to let us know that they want to be considered, and their materials will be reviewed. As a consequence, the fellowships usually come with their offer package. On the other hand, the Condesa, because of the cycle, they usually will instead they will send out calls for like first-year students when they are already here, and then they will do the selection from there on. So say for the applications, you will see the checkbox and the box for filling information for the GRISE, but for Condesa, then it's the application starts when the incoming students arrive.
Okay. Follow-up question. Thank you for that. If they request, or if they seek out or open up the applications to first-year students, if admitted, would we then be in like a limbo period for that first year regarding financial support, or would that still be covered? No. Okay.
Right. So the idea is that 5-year guarantee funding, in the sense that every student, if they are in good academic progress, they will receive 1 out of the 3. So like either TA, GSR, or fellowship. That's very important. And those programs, when they offer fellowship, they will work with like the department, so that it will be seamless. Like students don't need to be worried about this, and they will just if they are lucky, they will be put on fellowships, and they will be notified in advance. So
got it. Okay, thank you.
You're welcome. For other participants, if you have questions, you can simply unmute yourself and ask questions.
I have just one quick question for, here's a question. Why don't we go ahead with this?
Okay.
Yeah.
So for this cycle, we don't have we don't accept application for master program. So what happened is we will expect that our applicants are applying for the PhD program. Right now, say our students can get a master degree after they pass their qualifying exam. So it's called master along the way. Say right now we don't have like an individual separate master program that's open for accepting applications at this point. So say when you apply, we expect that the applicants are applying for a PhD study.
That's a good question. Go ahead, Alexander.
Hey, so for that, so I'm currently in my master's right now. Is there a potential for core courses to transfer, or is that
yes,
not
yes.
something?
So what
Okay.
happened is it's not called transfer. It's actually a waiver process. So what happened is when you come in, then so the requirement is that say then you talk to the instructors, okay, and if the instructor, so you can bring in the, for example, the syllabus and the homework and the exam, so that the instructor can check if it's about the same material that they will be taught during those courses. And if the instructor agrees, then what happens is then the student can file a petition to waive their course. Then you don't need to take the course again. So ideally, say in the most case, say a student can, in principle, okay, if the student already take those courses in other institute and if the materials are equivalent, a student can waive any of those 4 core courses and 1 electives. But the student still need to, even if you waive all this, the students still need to take 1 elective plus the seminar type courses like physics colloquials. But for core courses and 1 elective, if you already take those in other institutions, then when you come here, you can file petitions. You can talk to the instructor and then file petitions to waive them, so that you don't need to take them again.
Okay, thank you. And is it okay if I just keep going? Okay. For train of thought lost. 1 second. Okay. So if we waive or don't waive, say even if we have to restart it, the typical timeline is stating that you would begin research around year 2. Is it possible and or commonplace to start sooner than that?
Actually, our students usually start their research in year 1 because so what happened is, even though there are 4 core courses, right? It's like 2 in 1 semester and the other 2 in another semester. So students still have time, a little bit time for doing research, and that's why we have this rotation research to help students work with faculty and then see if they want to continue their research and eventually finish their PhD study in this group, or they can do a second rotation in another group before they settle in. Our students usually start for research like beginning their first summer and continue on. So we encourage students to do research as early as possible, and our faculties are also helping our students to do research as early as they can.
There's a question in the chat about housing.
Oh, okay. So for housing, what happened is, say, we don't have, at this point, as far as I know, we don't have in-campus housing for graduate students. So our students usually like, so they find like, so they either find roommates to rent like a house together, or they live in an apartment. on the other hand, I showed this like during the slide. Here at Merced, the living cost is reasonable, so our students are able to find reasonable housing options, as far as I know, and that the graduate division and also the graduate office in the School of Natural Sciences, they also help they also help distribute information for housing to help our students find to help them find like reasonable or suitable places to stay in Merced. I'm hoping that's useful information, but our students that, as far as I know, usually have no trouble finding reasonable housing in the Merced area compared to other places in California.
Mm-hmm.
I have another one, if that's okay.
Yes, go ahead, please.
Is there, because I know every program is different, is there, it's a follow-up to my question about how early you start research. Is it possible for a student plagued by an unnecessary amount of ambition to complete the program in less than 5 years? Or
certainly like but those are typical timelines, but as far as I know, as long as a student can finish all the courses or waive those courses and then pass qualifying exam and then finish thesis and submit thesis, there is no like timeline. Oh, okay. There is a 1 year residency requirement, but
okay, yeah.
right. So certainly you cannot finish faster than a year, but that's the only constraint. Other than that, like as long as you finish your thesis, you successfully defend your thesis and submit it to the school, then you are a PhD from the program.
Okay, got it. Thank you.
Right. You're welcome. There are more questions. So for the faculty here, do you have any more like things you would like to say to the students? Oh, looks like there is a, if I don't complete, yes, what happens if a student has not complete the language test?
So if you are an international student, you will be required to submit your IELTS or TOEFL in order for your application to be complete, unless you have received an advanced degree from a university where English was the primary mode of instruction. Then we could waive that. So Joy, for you, if you haven't taken your test yet, I would advise you to try to take it as soon as possible. And then when you take your test, you'll actually receive your unofficial scores at that time. And so we can use your unofficial scores to have you submit your application and for the faculty to begin their application review. And then at the same time, you should arrange to have the official scores sent over to us. And then that would actually complete your application because we could verify your test scores. Let me know if you have anything more specific that you want to know for that, but if it is a requirement, we would need it for the application.
Thank you, Jess. Yeah, if the audience have more questions, you can either unmute yourself and ask, or you can type them in the chat box.
I have another one.
Yes, go ahead.
Dr. Sharping, I saw on, and may I address you guys individually? Is that okay? Okay. I saw on the slide, you're in like 3 different areas for ongoing research. I know in your presentation, you were talking about, you know, the magnets and some low temperature stuff in there too. Do you, it's just a general question, because I know at this point in time, we're not currently joining which, or know what team we're going to join just yet. Do you, because regarding like the solar energy stuff for the condenser thing, do you handle any kind of materials synthesis in there at all, or not specifically that, or anything with like photovoltaics, anything around that?
So the solar and photovoltaics and materials for that sort of thing, I think you'd probably be better served to work with somebody other than me.
Okay.
I'm more of an optics person, so
Okay.
There's definitely overlap, and I serve on committees for some of the students who are in those areas.
Okay.
And maybe some of the characterization you might want to do, we could work together. So, I mean, when you have a research idea, or if you know, the right kind of opportunity comes up, then it may be that there's a good fit in my research group still, even though your high-level ambitions are to be in that space in your career in the future.
Mhm.
Like that might be okay, but I think that you might want to you know, you could look at Sai Ghosh's group. That'd be a good place to start.
That was one of the ones I was
Right.
saw so
And if you're more materials oriented, there's also some of the affiliate faculty. Let's see, if you wanted to do more of condensed matter like theory, there's Professor David Strubba.
Hep is on there too.
Right. So there's a couple of different ways you could go with that. Mine would be more of the physicsy way, and I think Professor Ghosh has a lot of physics, but also is a little bit more applied.
Okay, thank you.
Right,
definitely
and
look into
we
the
have a
website.
new professor, Professor Hui Cai. He is doing this novel 2-dimensional material synthesis, and Professor Cai is also affiliated with, I think it's Lawrence Berkeley National Laboratory. So his students can use the facility there to fabricate those novel materials as well. Okay. Any more questions from the audience?
I think I have one last one, just as a kind of like a follow-up for that. Is, because I know some universities do it, but everyone's different. I know like how funding is made available for individual students doing research outside of departments, things like that. If admitted and one of the research teams doesn't happen to align specifically like in physics, can you do interdepartmental? Is that allowed, or like they would become like your advisor? Your advisor has to be in physics, but you have like a co-advisor. Is that a thing, or that's normal? Okay, that just has to be discussed.
Right, that's why we have this affiliated faculty, right? So they are not physics faculties, but our students can can join their group, and they are certified to mentor physics students. So we have this mechanism so that our students can do like not just traditional physics research, but also kind of bridging different areas.
Okay, that's what you're talking about on that slide. Okay, cool. Thank you.
Right, and you can find you can also find the list of affiliated faculties on our website. So there is like physics faculty, but then there is another list. Those are affiliated faculty, which means they are not in physics department, but they are certified to mentor physics graduate students. So we have affiliated faculty from applied math, from chemistry, from mechanical engineering, from material science, from mechanical engineering. So like our students are doing lots of like interdisciplinary research here.
Got it. Okay, cool. Thank you.
Okay, I see that it's 1 o'clock already. So thanks everyone for joining the recruitment webinar. And you can find our email addresses on the chat box. So if you have any questions, you are welcome to contact any of us, and hopefully we can either answer your question or direct your question to the right place. Thanks everyone, and hope to see your application and also see you here at UC Merced. And with that, I will conclude our recruitment webinar today. Thank you, everyone.
Thanks, Chih-Chun.
Thank you.